Welcome back to the deep dive. Today, we are plunging into a topic that's not just abstract or theoretical, but one that's actively under construction all around us, really shaping the places we live and work, smart cities powered by the Internet of Things.
Mhm.
We've been given some really rich material for this exploration, a source titled Empowering Smart Cities Through IoT Challenges and Innovations.
Yeah, sounds like a good one.
It does. This isn't just a report. It seems to be a pretty comprehensive look at this complex area shared with us by a listener who wanted to really, get a handle on what's going on here.
That's great. Always good when listeners guide the deep dives.
Absolutely. So our mission, as always, is to unpack the source for you, to pull out the most critical nuggets of knowledge, the surprising insights maybe, and the practical realities of actually building these, well, interconnected urban environments. We're going to navigate the landscape the source lays out. The groundbreaking innovations, the real-world implications, the significant challenges faced by everyone from the engineers building the tech to the city managers deploying it, the strategic thinking required, and even a peek into what the future might hold.
It covers a lot of ground then.
It really seems to. I'm particularly fascinated by how something like the Internet of Things, often discussed in terms of smart homes or wearable tech, is fundamentally altering the infrastructure and operation of entire cities. But as this source clearly points out, it's far from simple.
That's absolutely right. And it's timely too. The source starts by grounding us in the current reality, highlighting the undeniable trends of rapid urbanization and burgeoning populations.
Right, more and more people living in cities.
Exactly. These aren't just statistics. They represent increasing pressure on finite urban resources and infrastructure. So understanding how technology, specifically IoT, can help cities manage this growth effectively and improve the quality of life for residents isn't just academically interesting.
No, it's practical.
It really is. As the source frames it, it's becoming an essential evolution. Our deep dive today is really driven by the need to understand this essential shift based on the insights this material provides.
Essential evolution. Okay, that sets a powerful tone. So, let's start where the source begins, defining what exactly a smart city is in this context.
Yeah.
It's a term we hear a lot, but what does this material tell us is at its core?
Well, the source presents smart cities not just as, an upgrade, but as the future of urban living. It describes them as an essential evolution in urban planning and infrastructure.
Okay.
That framing is crucial because it implies necessity, driven by those pressures we just mentioned. With millions more people moving into urban areas globally, the old ways of managing cities, well, they simply won't be sufficient.
Right, they won't scale.
Exactly. The why they were essential, as the source suggests, ties directly into the core goals driving this evolution. The material points to creating more efficient, sustainable, and responsive environments.
Okay, efficient, sustainable, responsive. Let's break those down maybe. What does efficiency look like here?
Think about efficiency in terms of resource management. Optimizing energy grids to reduce waste, managing water systems to prevent leaks, or streamlining public services. It's about doing more with the same, or maybe even less, which is crucial when populations are growing.
Makes sense. More people, same resources, need efficiency. And sustainable.
Sustainability, as the source notes, is another cornerstone. And this isn't just about, feel-good environmentalism. It's about the long-term viability of urban life itself.
Right. Can the city keep functioning long term?
Precisely. IoT can enable precise environmental monitoring, tracking air quality block by block, managing waste collection based on actual fill levels, not just schedules, optimizing traffic flow to reduce idling emissions,
Oh, interesting.
or ensuring efficient use of renewable energy sources that might be integrated into the grid. It allows for much smarter resource use from an environmental standpoint.
And the third one, responsiveness.
And then there's responsiveness. This is about how quickly and effectively a city can react to dynamic conditions and the needs of its citizens.
Like things changing moment to moment.
Exactly. Imagine traffic systems that instantly adapt to accidents or sudden congestion. Public safety systems that can deploy resources more effectively based on real-time data feeds. Or city services that can be accessed and delivered more seamlessly, maybe through an app or online portal that actually works well.
Okay, so reacting faster and better.
Yeah. The source puts these three goals, efficiency, sustainability, and responsiveness, at the core of smart city innovations. It emphasizes that the technology is a means to these specific ends, not, the end in itself.
That's a key distinction. The tech serves the goals. So the goals are clear, and the foundational technology enabling this, according to the source, is IoT. It's not just used in smart cities, but leveraged to create them. What's the significance of that distinction? Why say to create?
That phrasing, to create, it suggests that IoT is the fundamental building block. It's like the technological substrate, the foundation upon which the smart city is built.
Okay.
The source implies that IoT provides the means for a connected urban environment. What does that connected environment look like? Well, it's a city where countless devices, sensors embedded in roads, smart meters on buildings, connected cameras, environmental monitors, even smart waste bins are all collecting data in real time.
Wow, it's a lot of data
A
points.
huge number. And it's also a city where these devices and the systems they feed into can communicate and interact with each other. It's like the nervous system, the sensory organs, and maybe the early relay points of the smart city brain, if you want an analogy.
The city's nervous system, I like that. And why is this pervasive connectivity so fundamental to achieving those goals of efficiency, sustainability, and responsiveness?
Because all of those goals rely heavily on data, and crucially, the ability to act on that data quickly and intelligently. A connected environment means real-time visibility into what's happening across the entire city, or at least parts of it.
Seeing things as they happen.
Right. City managers can potentially see traffic jams forming, detect pollution spikes, monitor energy demand fluctuations, or identify infrastructure issues almost the moment they occur. This real-time data flow, enabled by that IoT connectivity, is what allows for optimized decision-making,
For example.
like adjusting traffic light timings dynamically based on actual flow, not just a preset schedule. Deploying maintenance crews proactively because a sensor detected a problem early, or sending out targeted alerts to citizens about, say, a localized air quality issue.
Got it.
Without that constant pulse of data from connected devices, the aspirations of efficiency, sustainability, and responsiveness, well, they remain largely theoretical. IoT makes them potentially achievable by providing the necessary information foundation.
That makes perfect sense. It's the data that fuels the smartness, and IoT is the engine for gathering it across this vast, complex environment. The source then brings up another critical layer, the interplay between technology and urban policy. This isn't just a tech deployment, it's deeply intertwined with how cities are actually governed. Based on what the source tells us, how does technology interact with urban policy? It seems technology acts as a powerful enabler first, right?
Yes, definitely. It opens up entirely new possibilities for managing the city. Think hyper-precise data collection on everything from noise levels to pedestrian flows, or the potential for autonomous systems managing aspects of traffic or logistics someday.
Things we couldn't do before.
Exactly. These new capabilities generate massive streams of data and introduce functionalities that didn't exist previously. This immediately creates a need for policy guidance. How should this data be used? Who owns it? What are the rules governing these new automated systems?
Right, the rules haven't caught up yet.
Technology creates new frontiers that policy must then navigate and regulate. It also inherently introduces new challenges, like those around privacy and security, which absolutely demand clear policy frameworks to address public concerns and establish rules of engagement.
Okay, so tech creates the need for policy. Conversely, how does urban policy influence the adoption and shape of smart city technology? Policy isn't just reacting, is it?
No, not at all. Policymakers aren't just reactive, they proactively set the conditions. They can establish regulations that either encourage or inhibit specific types of technology deployment. Think about rules around data sharing, for example. They can create incentives, financial or otherwise, for companies to develop solutions that align with the city's specific goals, like reducing carbon emissions or improving public transit ridership. Policy provides the necessary structure for technology to gain public acceptance by addressing those concerns we mentioned and ensuring accountability.
And setting the direction.
And perhaps most importantly, urban policy provides the overall strategic direction. It defines what the city is trying to achieve and how technology should be leveraged to support those broader urban planning goals. It ensures technology serves the city's vision for its residents rather than technology dictating the vision.
So it's a two-way street.
Absolutely. This interplay is, as the source implies, absolutely crucial. A smart city isn't simply a collection of gadgets and sensors. It's a system where technology is intentionally guided by policy to achieve specific urban outcomes.
Okay.
Policy provides the legitimacy, the regulatory environment, the ethical boundaries, and the long-term strategic vision necessary for technology to be deployed effectively, equitably, and sustainably across a citywide scale. It's a constant dynamic relationship, almost a dance, like you said earlier.
Yeah, a dance between what technology can do and what the city should do with it, all mediated by policy and governance. That's a great way to frame it. Now that we have the context of smart cities, their goals, and the role of IoT in policy, let's get a bit more specific. The source moves into the actual building blocks, highlighting the key IoT technologies shaping smart cities. What does this material identify as the pivotal technologies, and how do they contribute?
Right. Moving from the strategic to the, well, tangible. The source highlights a few core components that are fundamental to the technical architecture. It names sensors, edge computing, and cloud platforms
Oh,
as
my
particularly
goodness.
pivotal.
Sensors, edge, cloud. Okay.
These work together in a layered approach, really, to create that connected urban environment we discussed.
So how do they work together? Let's break down their specific contributions based on what the source implies for city goals. First up, sensors.
Okay, sensors. The source identifies them as key for data collection. Their impact in a city context is immense. These are the eyes and ears on the ground collecting that granular real-time information about everything.
Everything. Like
Yeah.
what?
Well, the flow of traffic at a specific intersection, the temperature and humidity in a public park, the fill level of a garbage bin, maybe the structural integrity of a bridge via vibration sensors, or the presence of available parking spots.
So tons of different types of data.
Exactly. Without this distributed network of sensors constantly gathering data, there's basically nothing for the smart systems to act upon. It's the raw input.
Got it. Raw data from sensors. Next, edge computing. What's that about? Sounds like it's happening somewhere specific.
Yeah, edge computing, this refers to processing data closer to where it's generated at the edge of the network, literally, rather than sending everything back to a central data center immediately.
Why do that? Why not send it all back?
Speed, mostly. The source implies its critical impact in enabling faster processing and response times. Why is this important in a city? Think about applications that require near-instant reactions, like controlling traffic lights based on real-time conditions right now, enabling communication between connected or even autonomous vehicles where milliseconds matter, or triggering an alert based on a security event detected by a camera right at that location.
Okay, yeah, you can't wait for data to go to the cloud and back for those.
Exactly. You can't afford the delay, the latency of sending data across the internet to a distant cloud platform for analysis and then waiting for an instruction to come back. Edge computing handles that time-sensitive processing locally, enabling those rapid responses essential for dynamic urban management and public safety.
So sensors collect, edge processes quickly for local action, and the third piece, cloud platforms.
And finally, cloud platforms. The source outlines their role for, well, data storage, processing, and enabling applications. The cloud provides the centralized, scalable infrastructure needed to handle the absolutely massive volume of data generated by a citywide network of sensors and edge devices.
The big picture view.
Precisely. This is where data from across different systems and locations can be aggregated, stored long-term, and analyzed for broader insights and trends. It's where complex analytics, machine learning models, which we'll probably get to later, and citywide applications for services or management dashboards typically reside.
Right.
The cloud acts as the central repository and processing hub, enabling that macro-level understanding and long-term planning based on all the data collected out at the edge and by the sensors.
So you really see how they form a system. Sensors gather the raw data, edge computing handles urgent local action, and the cloud provides the backbone for aggregation, deeper analysis, and those citywide services.
It's a complementary architecture.
That tiered architecture makes a lot of sense for managing the scale and speed needed in an urban environment. The source also mentions case studies of successful implementations. Even without specific examples listed in the material we have right here, what's the value of looking at these kinds of case studies in the context of smart cities? Why does the source highlight them?
Well, the source highlighting case studies underscores their importance for demonstrating proof of concept and, crucially, providing practical lessons learned.
Learning from what worked or didn't.
Exactly. In a field as complex and multifaceted as smart cities, seeing how these technologies are deployed in the real world is invaluable. Case studies provide concrete examples showing that these aren't just theoretical possibilities, but achievable realities. They demonstrate feasibility, illustrate successful approaches to both the technical challenges, like integration, and the urban or policy challenges, like securing public buy-in or navigating regulations.
So they show it can be done.
Right. And based on the goals and technologies we've discussed, these case studies would likely showcase quantifiable improvements in urban metrics. They might show, for instance, a documented reduction in traffic congestion after implementing a smart traffic management system.
Measurable results.
It's exactly. Or a measurable decrease in energy consumption in municipal buildings, thanks to smart metering and building management systems. Or perhaps enhanced public safety outcomes through better data utilization and resource deployment. The source including this point signals that looking at what's already working, the evidence, is a critical part of planning and strategic investment in smart city initiatives. You learn from others' successes and failures.
It provides that real-world validation, which must be essential when you're talking about potentially huge investments. The source also brings up a significant technical and logistical hurdle: integrating legacy systems with modern IoT solutions. Cities aren't built on greenfield sites. They have decades, sometimes centuries, of existing infrastructure. What does the source tell us about this challenge?
Oh, this is arguably one of the biggest practical challenges cities face. Legacy systems in a city are incredibly diverse. They include the old, sometimes analog infrastructure like aging water pipes, electrical grids that might date back decades, traditional traffic light systems controlled by outdated hardware.
Stuff that wasn't designed with the internet in mind at all.
Not even close.
Yeah.
And numerous disconnected departmental IT systems, managing everything from permits to public works records, often running on old software, maybe even different platforms that don't talk to each other.
Right. Silos everywhere.
Exactly.
Yeah.
The challenges in integrating modern data-centric IP-based IoT solutions with these often siloed, older systems are manifold. You face compatibility issues, getting new digital devices to talk to old analog control systems. There are vastly different data formats and standards, or often a complete lack of standards in older infrastructure, making data exchange incredibly difficult.
Yeah, I can imagine.
The physical age and condition of the legacy infrastructure itself can limit what's technologically possible or financially viable. You can't just slap a sensor on a crumbling pipe and expect magic.
Yeah.
And there are significant organizational challenges, too. Different city departments often operate their systems independently, sometimes with different priorities or even different vendors, making coordination tough.
So it's tech, physical infrastructure, and organizational hurdles.
All three. Yet, as the source implies, this integration is absolutely essential. Cities cannot afford, financially or logistically, to simply rip and replace all their existing infrastructure overnight.
No way.
They have to find ways to make their existing assets smarter and connected piece by piece. Integration ensures continuity of vital services while slowly phasing in new capabilities. It's fundamental to creating that citywide connectivity and data flow needed for a truly smart system, preventing new IoT deployments from becoming isolated islands of technology that don't benefit the whole.
So you have to bridge the old and the new.
Precisely. The source hinting at seamless integration strategies suggests that the material likely delves into approaches like using specialized gateways or adapters to translate between different protocols.
Like a universal translator for machines.
Kinda, yeah. Or employing middleware software that sits between systems to help them connect and exchange data, and focusing on establishing standard data interfaces so that even if the underlying systems are different, they can share information in a common format.
It sounds like knitting together systems that were never designed to talk to each other while the whole thing is still operational. A major, major undertaking.
It really is.
Now, after discussing the technology, the source pivots, and wisely so, to the potential downsides and risks, starting with the crucial area of data privacy and security concerns. This is where the human element and potential vulnerabilities really come to the forefront.
A critical area.
The source gives a very clear warning here. As cities become smarter, the risk of cyber threats increases. Let's dig into why that risk escalates so significantly in a smart city context based on what we've learned from this material about connectivity.
Well, think about the sheer scale we discussed. Instead of just securing a few main data centers or office networks, you're now potentially securing millions of diverse IoT devices scattered throughout the entire city, on lampposts, in buildings, in vehicles, underground maybe. Everywhere. And many of these devices, especially older or cheaper sensors, might have limited processing power or memory, making traditional security measures like strong encryption or complex authentication difficult, or even impossible to implement effectively. They weren't designed with robust security as the top priority.
So they're potentially weak points.
Potentially, yes. You also have to secure the complex, heterogeneous communication networks connecting all these devices. Maybe it's a mix of Wi-Fi, cellular networks like 5G, specialized low-power networks like LoRaWAN, fiber optics, etc. Each network type has its own security considerations.
Right.
And then there are the centralized cloud platforms storing the aggregated, potentially highly sensitive city data. Each device, each network segment, each platform represents a potential vulnerability, potential entry point for attackers. It vastly expands the attack surface compared to a less connected city.
More doors and windows for hackers to try.
That's a good way to put it. And the stakes in a smart city security breach are incredibly high. We're not just talking about financial data theft, though that's possible too.
What are we talking about then?
A successful attack could disrupt essential services like power, water, or transportation systems, with potentially catastrophic consequences for daily life and public safety.
Yeah, that's frightening.
It could involve the theft or misuse of extremely sensitive citizen data, think with detailed location tracking from connected vehicles or transit systems, behavioral patterns inferred from smart meter usage, energy consumption profiles linked to specific homes. Imagine that data getting out or being misused.
Huge privacy implications.
Massive. And in scenarios where IoT controls critical physical infrastructure, like traffic signals or water treatment plants, a breach could even lead to physical damage or harm. It crosses the line from digital to physical risk.
Okay, the risks are clear and significant. This high-stakes environment is precisely why the source emphasizes the critical importance of data security and privacy for maintaining citizen trust. Why is trust so paramount here?
It's paramount because smart cities fundamentally rely on the willingness of citizens to interact with and accept these technologies. Often, this involves the collection of data about their activities, their movements, their environment.
People have to be okay with it.
Exactly. If residents don't trust that the city is safeguarding their data and respecting their privacy, they will be resistant to adoption. They might withhold participation in feedback programs, avoid using smart services, and potentially push back politically against initiatives.
It could derail the whole thing.
It absolutely could. A single significant breach, or even just the perception of inadequate safeguards, could instantly erode years of effort to build confidence, undermining the entire smart city initiative. Trust isn't a secondary consideration. It's foundational to the social license for a smart city to operate.
Social license to operate, that's key. The source points to major security challenges in this domain. Beyond the scale and diverse devices, what other specific challenges does securing a citywide IoT network entail?
Well, think about managing authentication and access control. You have a huge number of users, citizens, city employees, maybe automated systems, needing different levels of access to different data and services. How do you manage those identities and permissions securely at scale?
Yeah, complex.
Securely updating and patching potentially millions of distributed devices, many in hard-to-reach locations, is another huge challenge. How do you keep them all up to date against new vulnerabilities? Detecting and responding to novel threats specifically targeting IoT networks requires new tools and techniques, and ensuring the resilience of critical systems against denial-of-service attacks, where attackers try to overwhelm systems to shut them down, is vital.
It sounds like securing a citywide network is fundamentally different and harder than securing a typical corporate network.
It is. The complexity, the number of endpoints, the diversity of environments, and the potential real-world impacts are all significantly greater.
It sounds like a security nightmare if not handled correctly from the start. The source then highlights the importance of best practices for safeguarding data. While the material might not list every single practice, what kinds of principles would these best practices embody? Given the risks involved, what should cities be doing?
Given the context of high-stakes urban data, these best practices would necessarily focus on robust data protection throughout its entire life cycle, from collection to storage to use to disposal.
Okay, like what?
This would certainly involve encrypting data, both when it's stored at rest, on servers or devices, and when it's being transmitted across networks in transit. That's fundamental. Strong access controls are vital, ensuring that only authorized individuals or systems can access specific types of data based on the principle of least privilege, meaning they only get access to what they absolutely need.
Don't give everyone the keys to everything.
Exactly. Regular security audits and vulnerability testing are crucial to proactively identify weaknesses in the vast network before malicious actors do. Think of it like regular checkups, and having detailed, well-rehearsed incident response plans is non-negotiable.
Planning for when things do go wrong.
Because breaches can happen, even with the best defenses. Rapid, effective response is key to limiting damage and, importantly, maintaining that citizen trust we talked about. And a core principle woven into effective strategies, as mentioned in the source implicitly, is security by design.
Security by design.
Yeah. I mean, security isn't something you bolt on as an afterthought once the system is built. It's integrated into the architecture, the development process, the procurement choices, right from the very beginning. It has to be baked in.
Makes sense. And finally, in the security section, the source brings up the role of compliance and regulatory frameworks. Why are these essential in the smart city security landscape? Isn't strong tech enough?
Tech is necessary, but not sufficient. Compliance and regulatory frameworks provide the essential legal and structural backbone. They establish clear rules for how citizen data must be handled, ensuring a minimum standard of privacy and security across potentially diverse city projects and different vendor solutions.
Setting a baseline standard for everyone.
Exactly. They mandate requirements for data storage limitations, rules around consent for data collection, limitations on how data can be used, and procedures for breach notification if something goes wrong. They ensure accountability by clarifying legal responsibilities.
So people know who's responsible.
Yes. Without these frameworks, there's no consistent standard. It could be the Wild West, leaving citizens vulnerable and creating uncertainty for developers and operators. Regulations, whether there is general data protection laws like GDPR or CCPA, or maybe regulations specific to certain sectors like transportation or utilities, provide the necessary boundaries. They guide technical managers and developers.
So they know the rules of the game.
Right. They underscore that smart city systems must not only be technologically functional, but also legally compliant, ethically sound, and designed in a way that builds and maintains public trust. They translate societal values around privacy and security into concrete technical requirements that everyone has to follow.
Okay, so security and privacy aren't just technical problems. They're fundamentally tied to trust, best practices, and the legal structures governing how technology interacts with citizens. Moving from that crucial area of challenge, the source makes another vital pivot to citizen engagement and participation. It's easy to talk about smart tech, but who is it all for? The people, right?
Exactly. The human element.
The source makes a very strong statement here, emphasizing that understanding public sentiment and engaging citizens are crucial for a successful smart city initiative. That word crucial isn't passive language. It implies that success is pretty much impossible without it. Why is this so non-negotiable, according to the source?
It's non-negotiable because smart cities directly impact the daily lives of the people they serve. They change how people navigate their neighborhoods, how they access public services, how they use utilities, and potentially how they are monitored or how their data is used.
It affects everyone.
Profoundly. The success of any smart city initiative hinges on its adoption and acceptance by the residents. If the solutions don't meet their actual needs, if they don't address their concerns, or they're perceived as intrusive, creepy, or inequitable, people simply won't use them.
Or they'll fight against them.
Or worse, yes, they will actively resist them. Engagement ensures that smart city projects are solving real problems for real people and are developed in a way that aligns with community values and priorities. It's how you build that essential buy-in and foster a sense of ownership.
What happens if cities skip this step or just pay lip service to it?
Neglecting genuine citizen engagement carries significant risks. It can lead to well-intentioned, maybe expensive, projects being underutilized or ignored. It can spark public backlash against initiatives perceived as surveillance-oriented or disruptive without clear benefits. Or it can result in projects failing to deliver their intended benefits because they weren't designed with actual user needs or specific local contexts in mind.
Designing in a vacuum.
Pretty much. And trust, which we just discussed in the context of privacy and security, is also built through open and transparent engagement. If people feel they're part of the process, they're more likely to trust the outcome.
Okay, so engagement is critical. How does the source suggest cities incorporate citizen feedback into these strategies? What methods are important? It's not just about telling people what's happening, right?
No, definitely not. The source highlights methods for incorporating citizen feedback into IoT strategies. This moves beyond simply informing the public. It's about creating a genuine feedback loop, a two-way street.
So what might that look like in practice?
Based on the nature of smart city projects, this can involve things like conducting public consultations early on, before major decisions are made about proposed technologies or projects, running surveys to gauge resident priorities and concerns, especially around sensitive things like new data collection or surveillance tech.
Asking people what they think first.
Yes.
Yeah.
Involving community members in user testing of new smart services or applications to see if they're actually usable and useful, and establishing accessible feedback mechanisms, maybe through city websites, dedicated apps, community forums, even kiosks in public places, where citizens can easily report issues or provide input on their experiences with smart city services.
Making it easy to give feedback.
Crucial. How does this feedback loop improve smart city development? Well, it's invaluable for ensuring relevance. It helps city planners and technologists prioritize projects that address the most pressing community needs, not just the coolest tech.
Right.
It identifies pain points in existing services that technology could potentially help solve. It allows for refining the design and user interface of smart services to be more intuitive and accessible for everyone, including people with disabilities or lower tech literacy. And it's essential for proactively identifying and addressing potential ethical implications or privacy concerns before deployment rather than reacting to public outcry later.
So it makes the end product better and less likely to cause problems.
Essentially, yes. It helps ensure that technology serves the community rather than the other way around.
And are there specific tools and platforms for citizen engagement that the source might be referring to? Is tech itself part of the solution here?
It certainly can be. While the source probably doesn't list specific products, the mention of tools and platforms suggests that technology itself can be an enabler of engagement, ironically. This could include developing dedicated city portals that provide transparent information about smart city initiatives, what's being planned, what data is collected, how it's used, and offer clear channels for feedback. Building mobile apps that allow residents to easily report issues, like potholes or broken streetlights, maybe with automatic geotagging.
Like a 311 app on steroids?
Kind of, yeah. Or apps to access real-time city data that's relevant to them, like transit schedules, air quality indices, or energy grid status. Or even using online forums or digital platforms for things like participatory budgeting, where citizens can directly influence how some local funds are spent on projects.
Giving people direct input.
Exactly. Why are specific tools important? They can make engagement more accessible and convenient for a wider range of residents, potentially reaching people who wouldn't attend a traditional town hall meeting. They can also help systematize the collection and analysis of feedback at scale, which is crucial in a large, diverse urban environment.
Using tech to manage the feedback process itself. Interesting. The source also touches on something very modern: the impact of social media on city planning. How does social media fit into this picture of engagement in planning? Feels less formal, maybe harder to manage.
It is less formal, and that's part of its impact. Social media acts as a real-time, often unfiltered, barometer of public sentiment. For city planners and managers, monitoring social media can provide immediate insights into what residents are talking about, what concerns they have, what initiatives are being praised or criticized, and what emerging issues are gaining traction, sometimes before they surface through official channels.
Like an early warning system.
It can be, yes.
Right.
It's also a channel for rapidly disseminating information from the city, although cities must also contend with the potential for misinformation or rumors to spread just as quickly through these same channels. That's a challenge. And social media can also be a powerful tool for community organizing. Residents can quickly mobilize support for or opposition against proposed projects using these platforms, which can significantly influence the planning process and political decisions.
So cities have to pay attention.
They really do. City planners and managers need to pay attention to social media because it's a significant, dynamic, and highly visible channel for public feedback and sentiment. It can highlight issues that might not come up through formal channels and can rapidly shape the public narrative around smart city initiatives, impacting their feasibility and acceptance, for better or worse.
And finally, in this citizen engagement section, the source highlights successful community-driven smart city projects. What makes these stand out? What's different about them?
These projects are particularly powerful, often because they originate from the community itself or are co-designed from the start. They're addressing specific local needs identified by the residents or local groups, not imposed from the top down.
Grassroots smart city initiatives.
Exactly. Because they are community-driven, they tend to have strong buy-in and active participation from the very beginning. People feel invested.
Why do they tend to be successful, according to the source's implication?
Their direct relevance to local priorities ensures that the technology is being applied to solve real, felt problems, not just theoretical ones. The deep involvement of community members fosters that crucial sense of ownership and investment in the project's success and sustainability. They demonstrate that smart city initiatives can be co-created with citizens, building trust and leading to sustained engagement and often better outcomes that truly align with local needs and aspirations.
It's a powerful reminder that the smart in smart city ultimately refers to serving the intelligence and needs of its human inhabitants, not just the tech itself.
Well said.
Building on the discussion of technology, challenges, and people, the source brings us back to a recurring theme, a really tough one: navigating the challenges of integration. We touched on legacy systems earlier, but the section likely expands on the complexity of making all these disparate systems work together on a citywide scale.
Yes, it's a thread that runs through the whole discussion.
Let's revisit the challenges of integrating new IoT solutions into existing urban infrastructures. What are the unique complexities tied specifically to the urban environment itself, as the source suggests? We touched on scale, but what else?
Right. Integration is a persistent challenge, definitely amplified by the unique environment of a city. The sheer scale and density are primary factors, as you said. You're integrating systems across vast geographical areas, dealing with potentially millions of devices and petabytes of data, all within a densely packed physical environment.
Yeah.
This density creates physical obstacles for wireless communication. Tall buildings, blocking signals is a classic example. Environmental factors inherent to cities, things like pollution that can degrade sensors over time, extreme temperatures affecting electronics, or even electromagnetic interference from other systems, like power lines or transit systems, can significantly impact the reliability of IoT deployments.
Stuff you don't worry about in a controlled lab setting.
Exactly. Then there's the complexity of the physical infrastructure itself. Roads, bridges, tunnels, underground utility lines carrying water, gas, electricity, communications, buildings of various ages and construction types. Integrating sensors and communication networks into this existing physical fabric presents significant engineering challenges. You can't just drill holes anywhere.
And the organizational side again.
And the organizational complexity, yes. Cities are often structured into numerous departments: transportation, water, energy, public safety, waste management, parks, and so on. Each might have their own existing systems, their own data silos, their own operational procedures, and frankly, their own priorities and budgets. Getting these disparate entities to collaborate effectively and integrate their systems is often a major political and organizational hurdle, not just a technical one.
So it's not just a technical problem of connecting pipes, but connecting departments and budgets too. The source talks about best practices and strategies for seamless integration. Given these massive complexities, what kinds of approaches are crucial for navigating this? How do you make it seamless?
Well, seamless might be aspirational, but the source pointing to best practices suggests that effective strategies exist despite the difficulty. Key approaches would involve prioritizing the adoption of open standards and protocols.
Open standards. Why is that important?
It means using communication methods, like standardized protocols such as MQTT or CoAP for device communication, and data formats, like common structures using JSON or XML, or even industry-specific standardized data models that are not proprietary to a single vendor. This is crucial because it allows devices and systems from different manufacturers and different city departments to communicate and exchange data without being locked into one company's ecosystem. It promotes choice and flexibility.
Prevents vendor lock-in.
Exactly. Developing flexible and modular system architectures is also vital. Instead of building huge, monolithic, all-or-nothing systems, smart city solutions should ideally be designed in smaller, independent modules that can be updated, replaced, or integrated with other systems more easily over time. Think building blocks, not one giant sculpture.
Easier to swap parts out.
Right. Utilizing middleware or specialized integration platforms, software designed specifically to act as translators and connectors between disparate systems, is another critical strategy. They bridge the gaps. And relentlessly focusing on data interoperability is paramount.
Interoperability, that sounds key.
It is. It's about ensuring that data exchanged between systems is not only transferred correctly, but also understood and usable by the receiving system. It's about shared meaning, not just shared bits.
Interoperability seems like a core concept here, maybe worth digging into. The source specifically mentions frameworks for interoperability between devices. Can you elaborate on why having these frameworks is so critical in a smart city? Why isn't just using open standards enough sometimes?
Open standards are a foundation, but interoperability frameworks often go further. They are foundational for preventing that siloing of smart city solutions we keep mentioning. Interoperability, in this context, means The ability of different devices, systems, and applications, potentially of different vendors, using different underlying technologies, deployed by different city departments to work together smoothly and exchange data effectively, almost as if they were designed as one system.
Making the different parts act like a team.
A good analogy. Why is this absolutely critical? Without interoperability, your smart traffic system might collect incredible data. But if it can't share that data seamlessly with the city's environmental monitoring system, you lose the opportunity to, for example, dynamically route traffic to reduce congestion in high pollution areas based on real-time air quality readings.
Connecting the dots between different systems.
Exactly. If your smart water system data can't be easily integrated with energy consumption data from the utility, you can't optimize energy use for water pumping stations based on real-time electricity prices or grid load. Siloed systems limit the potential for these powerful cross-cutting insights, for holistic city management, and for creating truly integrated services for citizens.
So how do frameworks help?
Interoperability frameworks provide the common technical standards, specifications, data models, APIs, application programming interfaces, and sometimes even testing procedures that everyone involved in the city's smart ecosystem agrees to follow. They establish the rules of engagement for how systems connect, communicate, and share data reliably. This ensures that components can plug and play, making the whole system potentially much greater and smarter than the sum of its parts.
It's the difference between having smart components scattered around and having a truly smart system operating cohesively. The source also brings up challenges unique to urban environments, again, within this integration context. What specific difficulties might arise that you wouldn't face in, say, integrating systems within a single large factory or campus?
Right, beyond the general complexities, urban environments add specific wrinkles. We touched on physical obstacles like buildings interfering with wireless signals, but also consider the harshness of the environment for sensors, extreme temperatures degrading electronics, corrosive elements in the air, especially in industrial areas or near coasts, constant vibration from heavy traffic impacting sensitive measuring equipment.
Things just break more easily outdoors.
Potentially, yes, or require more robust, expensive hardware. The sheer volume and velocity, the speed of data generated in dense urban areas require exceptionally robust and high-bandwidth communication network, which are complex and costly to deploy ubiquitously across a city, especially ensuring equitable access in all neighborhoods.
The data deluge.
Absolutely. Security risks are also amplified by the density and diversity of devices often located in easily accessible public spaces, making them potentially harder to physically secure and monitor compared to devices within a controlled corporate environment. And something as basic as managing power supply for thousands or millions of distributed devices, especially in remote locations, older historical areas without easy access, or places needing battery power, presents unique logistical and maintenance challenges.
Yeah, changing batteries on sensors on top of every lamppost sounds like a nightmare.
It's a real operational consideration.
And who is responsible for tackling all these integration headaches? The technical, the physical, the organizational. The source highlights collaboration between public and private sectors. Why is this collaboration essential specifically for navigating integration challenges? Can't the city just hire companies to do it?
They often do hire companies, but true collaboration is usually deeper and more necessary. It's almost always essential because neither the public sector, the city government, nor the private sector typically possesses all the necessary resources, expertise, or authority alone to make large-scale smart city integration work.
They bring different things to the table.
Exactly. Cities, the public sector, have the existing infrastructure, the roads, the lampposts, the buildings where things can be installed, the regulatory authority to grant permits and set rules, access to essential public data, and crucially, the mandate to serve the public good and ensure equity.
Okay.
However, they often lack the cutting-edge technical expertise in rapidly evolving fields, the agile development capabilities needed for iterative projects, and sometimes the significant upfront capital investment capacity that private sector tech companies possess.
And the private sector?
Private sector companies bring technological innovation, specialized skills in areas like AI, advanced data analytics, complex network management, and the ability to develop and deploy sophisticated solutions relatively quickly. But they need access to the city's physical space, potentially its data assets, and they need to operate within the city's policy framework and understand its goals. They can't just deploy tech in a vacuum.
So they need each other.
Pretty much. Collaboration, often structured through public-private partnerships, PPPs, long-term service contracts, or joint development ventures, allows both sides to pool resources, share expertise, and align incentives. By working together, they could leverage the city's assets and mandate, alongside the private sector's innovation and resources, to tackle the complex technical, physical, and organizational hurdles of integrating diverse systems across an entire urban environment. It helps ensure that the solutions developed are both technically feasible and aligned with public goals, not just commercial ones.
That makes sense. It requires a partnership approach.
This leads us naturally, actually, to the next section the source addresses, the role of government and policy. While technology and integration are crucial, government isn't just a passive recipient or facilitator, it's an active shaper of the entire smart city landscape.
Right. We talked about policy influencing tech adoption earlier. How does the source frame the overall role of government here?
The source's point seems clear and fundamental. Policies set the stage for smart city development. How does government policy provide this crucial foundation? Well, it's the mechanism through which the city defines its vision for being smart in the first place. What problems is it actually trying to solve with all this technology? What are the priorities?
Setting the goals.
Setting the goals, exactly. Policy allocates resources directing public funding through budgets, setting up grant programs, or creating structures and incentives to attract private investment. It establishes the critical legal frameworks, particularly around those sensitive areas of data privacy, cybersecurity standards, and the acceptable use of potentially intrusive technologies like surveillance cameras.
The rules of engagement again.
Yes, it streamlines regulatory processes needed to deploy the physical infrastructure, like getting permits for installing sensors or 5G small cells on city property. And it plays a key role in managing the inherent risks associated with introducing complex, interconnected systems into the public realm, thinking about liability, resilience, and ethical considerations.
It sounds like policy touches almost everything.
It really does. The source captures a vital tension here, noting that government policy plays a dual role, facilitating IoT initiatives while simultaneously addressing public concerns. This directly connects back to our earlier discussion on privacy, security, and that all-important citizen engagement. Effective policy doesn't just enable the tech, it ensures it's deployed responsibly, ethically, and with public acceptance and trust.
So policy is both an accelerator and a guardian, a facilitator and a regulator. The source mentions insights into effective policymaking in this context. Based on everything else in this material we've discussed, what might effective smart city policy look like? What are its characteristics?
That's a good question. Drawing from the themes that seem to run through the source, the rapid change, the complexity, the human impact, effective policy would need to be inherently adaptable.
Adaptable how?
Given the incredibly rapid pace of technological change in AI, IoT, communications, etc., policies written today need to be flexible enough to accommodate innovations and challenges that might emerge in the next few years without becoming instantly obsolete, maybe focusing on principles rather than specific technologies.
Okay, flexible. What else?
It needs to be collaborative. Effective policy development should involve input from a wide range of stakeholders: technologists, urban planners, legal experts, citizens themselves, privacy advocates, community groups, and industry players. This ensures all perspectives are considered and potential impacts, intended and unintended, are better understood.
Not just decided behind closed doors.
Ideally, no. It should also be forward-looking, trying to anticipate future trends, like the widespread adoption of AI in city management, or the profound implications of autonomous vehicles for urban mobility and land use. And, critically, it must be outcomes-focused, tied explicitly to improving specific aspects of urban life, not just deploying tech for tech's sake, but doing so clearly to enhance efficiency, sustainability, livability, equity, or resilience. Effective policy carefully balances fostering innovation with protecting the public interest, managing risks, and navigating those complex ethical considerations like fairness and bias in algorithms.
That's a tall order for policymakers.
It requires a sophisticated balancing act.
The source again mentions collaborations between cities and tech companies, but this time from the specific angle of policy. Why does policy need to govern these collaborations, which, as you said, are often key to implementing smart city projects? Why not just let them work it out in contracts?
Contracts are part of it, but policy sets the overarching framework within which those contracts operate. Policy is essential to ensure these partnerships genuinely serve the public good, not just private profit motives.
How does policy ensure that?
It needs to govern things like procurement processes. How does the city choose its tech partners? Policy should ensure transparency, fairness, and competition to get the best value and avoid corruption or favoritism. Crucially, it must establish clear rules around data ownership and use.
The data question again.
Always. Who owns the vast amounts of data generated by sensors deployed on public infrastructure, often by private companies? How can that data be used by the city? How can the company use it? Can it be monetized? And if so, how are the benefits shared with the public whose data it is, effectively? Policy ensures that private sector involvement aligns with clearly defined public goals, prevents vendor lock-in, where a city becomes overly reliant on one company's proprietary systems, and establishes robust accountability mechanisms for service delivery, security standards, and data handling practices.
So policy protects cities' interests and the public's interests in these deals.
Exactly. Without clear policies governing these collaborations, cities risk ceding too much control over public data, critical infrastructure, and even future policy choices to private interests in ways that may not ultimately benefit their residents or align with democratic values.
Got it. And finally, under the policy umbrella, the source points to funding and investment opportunities for smart city projects. Why is this a matter of policy? Isn't it just about finding the money?
Finding the money is the policy issue, often. Governments are frequently key players in initiating and structuring the investment needed for these large-scale projects.
How so?
Policy directly allocates public budgets towards smart city initiatives. It establishes mechanisms for cities to apply for grants from regional or national governments, specifically earmarked for smart infrastructure or innovation. And crucially, policy can create the framework and incentives necessary to attract private sector investment, which is often essential given the costs involved.
Making it attractive for private companies to invest.
Right? Smart city infrastructure, the sensors, the networks, the platforms, the integration work is often very capital intensive, requiring significant upfront funds.
Yeah.
Policy attracts that needed investment by creating a stable and predictable regulatory environment. Investors feel more comfortable putting money into projects where the rules of the game are clear and unlikely to change drastically overnight.
Predictability matters.
Very much so. Policy also helps define the scope, potential risks, and potential returns of smart city projects, making them more understandable and potentially attractive as investment opportunities, and demonstrating a strong, consistent political commitment from city leadership towards long-term smart city development signals to potential investors that the city is a serious, reliable partner. Policy, in essence, enables the financial mechanisms needed to turn ambitious smart city plans into tangible reality.
So government and policy aren't just bureaucratic hurdles. They are the essential framework and catalyst for setting the vision, securing the funding, managing the risks, and ultimately ensuring smart cities are developed in a way that benefits the public.
That's a good summary of its importance.
That brings us to the final section the source explores, looking ahead. Future trends in smart cities. After laying out the foundations and challenges, what does this material see on the horizon?
Right, the forward-looking part. The source asks, what's next for smart cities? And focuses on emerging trends, specifically highlighting two key areas, AI integration and sustainable practices.
AI and sustainability.
Yes, and it gives us a time frame, suggesting these are major shifts expected as we look ahead to the next decade. So not sci-fi, but near-term evolution.
Okay, let's dive into that first trend. How AI and machine learning enhance urban living. We've touched on data collection. AI seems like the next logical step to actually use that data effectively.
It really is. It's a natural evolution. You collect vast amounts of data via IoT, but data alone isn't insight. AI and ML are the tools that can make sense of this data at scale, identifying complex patterns, making predictions, and automating complex decision-making in ways humans simply can't, especially in real time across a whole city.
So how will AI and ML specifically enhance urban life based on the capabilities implied by the source? What can they do with all that city data?
Well, the source suggests several areas. AI can enable predictive maintenance for critical infrastructure. Imagine analyzing data from sensors on bridges, roads, or utility networks to predict potential failures before they occur.
Fixing things before they break.
Exactly. Allowing for proactive repairs, preventing costly emergency fixes, and avoiding service disruptions for citizens. That's a huge potential benefit. AI can optimize complex systems like traffic flow in real time, not just reacting to current congestion, but potentially predicting where and when it will occur based on historical patterns, weather events, etc., and then proactively adjusting signals or suggesting alternative routes to drivers or transit systems.
Getting ahead of the traffic jam.
Hopefully. AI can also personalize public services. Think about optimizing waste collection routes based on actual bin fill levels reported by sensors, saving fuel and time. or suggesting personalized public transport options based on real-time network conditions and maybe even a user's stated preferences or past behavior.
Tailoring services.
To some extent, yes. It can analyze patterns in energy consumption across neighborhoods or building types to identify inefficiencies or potential grid overloads, helping manage demand. And it can enhance public safety, perhaps by analyzing data from various sources, sensor data, public reporting, maybe even anonymized camera feeds to identify potential risk areas, optimize patrol routes, or speed up emergency response deployment by predicting needs.
Why is AI considered so transformative here? We have data analysis now.
It's transformative because it moves cities beyond simply reacting to events based on real-time data, or even just analyzing past trends. AI enables cities to become predictive, proactive, and significantly more efficient and potentially even automated in their operations and resource allocation. It allows cities to manage a level of complexity and derive insights from data at a scale and speed that was previously impossible.
Okay, so AI makes the city more proactive and intelligent in its operations. The source also focuses specifically on the concept of smart mobility and its implications. This seems like one of the most visible areas where technology is changing urban life already.
Absolutely. It's very tangible for most people. Smart mobility is really about creating a more integrated, efficient, safe, and sustainable transportation system for the whole city, using technology and data as the glue.
What does that involve? What are the pieces of smart mobility?
It includes several interconnected elements. Connected vehicles that can communicate with infrastructure like traffic lights and with each other, V2X communication, warning about hazards, optimizing flow. This also lays the groundwork for wider adoption of autonomous vehicles in the future.
Cars talking to each other in the road.
Essentially, yes. It involves integrated public transit systems that provide real-time arrival information, seamless payment across different modes, bus, train, subway, maybe even bike share, and multimodal journey planning tools that help you figure out the best way to get from A to B using any combination of options.
Making public transport easier to use.
That's a key goal. It covers smart parking management systems that use sensors or cameras and data analytics to guide drivers directly to available spots, reducing that frustrating circling for parking which causes congestion and pollution. And it's about effectively integrating on-demand shared mobility services like ride-sharing, car-sharing, e-scooters, bike rentals into the overall urban transport fabric, making them viable alternatives to private car ownership.
So a whole ecosystem of connected transport options. What are the implications for urban living, as the source prompts us to consider? This sounds like it could change cities quite a bit.
The implications are potentially vast, yes. Smart mobility holds the promise of significantly reducing traffic congestion by optimizing flow, enabling better traffic management, and encouraging shifts to more efficient modes like shared transit or micromobility.
Less time stuck in traffic.
That's the hope. It's strongly linked to sustainability goals by promoting shared and electric vehicles, optimizing routes to reduce fuel consumption and emissions, and making non-car options more attractive. It can improve accessibility, making it easier for all residents, including the elderly or those with mobility challenges, to get around the city independently.
More freedom of movement.
Potentially.
Yeah.
It might even influence urban design in the long run. If autonomous vehicles become widespread and parking needs decrease, cities might be able to reclaim valuable urban space currently dedicated to parking lots and garages for parks, housing, or other uses.
Wow, changing the physical city.
It could. And crucially, smart mobility also raises complex new policy and ethical questions. Things like safety regulations and liability for autonomous systems, ensuring fair and non-discriminatory access to new mobility options for all income levels and neighborhoods, managing the huge amounts of data generated by connected vehicles, and figuring out how public and private transport providers should collaborate and share data.
So, huge potential, but also big questions to answer. Building on these trends, AI and smart mobility, the source makes predictions for the next decade. While we don't have the specific crystal ball predictions from the material here, what types of developments can we reasonably anticipate based on the trends highlighted? What's the likely direction?
Based on the source's emphasis on AI and smart mobility, combined with the foundational elements of IoT, data and integration we discussed earlier, we can anticipate several key developments becoming more mainstream in the next 10 years or so.
Such as?
There will likely be a much deeper and more widespread integration of AI into core city operations, moving beyond pilot projects and niche applications to become commonplace in areas like utility management, predicting demand, optimizing grids, infrastructure monitoring, predictive maintenance becoming standard, and dynamic personalized service delivery. AI won't be novel. It'll be part of the plumbing.
AI everywhere in city management.
Increasingly, yes. We can also expect significant advancements and broader adoption in smart mobility solutions. Maybe not fully autonomous cars everywhere yet, but certainly more connected vehicles, more sophisticated traffic management, more integrated transit systems, and potentially noticeable shifts in how people commute and travel within cities, with shared mobility playing a bigger role.
Mobility changing visibly.
I think so.
Yeah.
There will probably be an even greater focus on using data and AI explicitly to drive sustainability initiatives, making cities measurably more energy efficient, reducing waste, improving air and water quality based on real-time optimization. The green aspect becoming more data-driven.
Using tech for sustainability goals.
Definitely. And overall, cities will likely become more adaptive, more predictive, and potentially more automated in many aspects of their day-to-day management, relying heavily on the continuous flow of insights derived from their connected IoT infrastructure and the AI analyzing it. The city itself becomes more like a complex, responsive, data-driven organism.
An incredibly complex, responsive, and data-driven organism. That's quite a vision. To bring all of this together, then, the source provides a summary and key takeaways. After covering all this ground, what are the core messages it wants to leave with the reader? What are the essentials to remember?
Well, the source's overall message, as reiterated in the summary section apparently, is the revolutionary potential of IoT in transforming urban landscapes into smart cities. It maintains an optimistic view of what's possible, but importantly, it seems grounded in the realities and challenges discussed throughout. It's not just hype.
Okay, potential, but with caveats. What are the specific key takeaways the source explicitly lists?
The material explicitly lists several key takeaways that really encapsulate the journey it takes us on. These include, unsurprisingly, the critical importance of data privacy and security, constantly linking the technology back to the need for citizen trust. The absolute necessity of community engagements, highlighting again that technology must serve the people, not the other way around.
Privacy and people first.
Exactly. Then, the significant challenges, but also the strategies for technology integration, acknowledging the practical hurdles of knitting old and new systems together, but pointing towards solutions like open standards and interoperability. And finally, the foundational role of government support and well-crafted policy, recognizing that policy, funding, and leadership are essential enablers for any of this to happen successfully and responsibly.
Those four seem to capture the main pillars: privacy, engagement, integration, policy.
They do seem to be the core, recurring themes. The source also apparently frames the value of its insights for different audiences, which is interesting. It notes that developers reading it can gain insights into the specific technical challenges and solutions required to actually build these complex systems.
Or the tech folks.
Right. While technical managers, or maybe city leaders, can learn how to align strategies with public interests and compliance. So understanding the broader context beyond just the code and hardware, the human factors, the policy landscape, the security implications, the ethical dimensions.
Bridging the tech and the strategy.
Yes, and ultimately, the source concludes by reiterating that these insights, understanding the tech, the challenges, the human factors, the policy needs, are all essential ingredients for driving successful IoT adoption. And the end goal of that adoption isn't just tech deployment, but leading ultimately to the creation of smarter, more resilient urban environments. It's a holistic view of what success requires and what it looks like.
Wow. That was a truly comprehensive deep dive into that source material. It really laid out the vision of the smart city, detailed the foundational technologies like sensors, edge, and cloud that make it possible, unpacked the significant hurdles around privacy, security, and that massive challenge of integration, stressed the absolute necessity of citizen involvement and supportive, thoughtful policy, and gave us a glimpse into a future increasingly shaped by AI and smart mobility.
It covered a lot of interconnected pieces.
It really did. It's clear this isn't just a technical shift, is it? It's a societal, governmental, and even ethical one, too.
Absolutely. The technology is just one part of the equation.
Well, thank you for joining us on this exploration, unpacking this source on empowering smart cities through IoT. It's a topic with, frankly, immense potential, but also significant complexity and vital considerations that go way beyond the technology itself.
Agreed. Lots to think about.
And that leads us perfectly to our final provocative thought for you, the listener, to consider. Pulling together that vision of a smart, efficient, data-driven picture with the crucial human and governance challenges this source highlights. Considering the incredible potential of AI and IoT to make cities efficient and sustainable, as outlined in this source, how do we ensure that this push for smartness always prioritizes the well-being, the privacy, and the active participation of the people who actually live there, ensuring the smart city truly serves its citizens first and foremost?
That's the fundamental question, isn't it?
It really feels like it is, something to reflect on as you see your own city evolving around you. Until next time, keep digging deep.